Halogenoalkanes can be prepared by a number of methods, and one of the method is free radical substitution in alkane. Free radical substitution in alkanes. Here you can see that an alkane, for example, methane, can be converted into methyl chloride in presence of UV light, and similarly, if you are having methyl chloride, it can be converted into methylene dichloromethane, methylene chloride or dichloromethane. So this is the chloromethane and this is dichloromethane. And you can carry out the same reaction with ethane if you have CH3CH3 and you react with chlorine or bromine. Here I have shown reaction with bromine. So in presence of sunlight, it undergoes free radical substitution reaction and it produces chloroethane. And if chloroethane undergoes the same reaction, I'm sorry, it should be bromo because we have reacted it with bromine. And if we react it further, the same reagent, bromine in presence of UV light, it produces two products because there are equal chances that whether bromine attached to the same carbon atom or the other carbon atom. So two products are possible here. So one was already on this carbon atom and another can come to this carbon atom as well. So two products are possible here and one is called 1,1-dibromoethane while the other one is 1,2-dibromoethane. So two isomers are formed here and this is bromoethane, and similarly you can draw any other halogenoalkane from an alkane by using this method. And if you have a cycloalkane, this is cyclohexane. Cyclohexane, it can undergoes the free radical substitution reaction with the same manner. So it produces chlorocyclohexane. If you continue this reaction, then it can produce different isomers. So this is chlorocyclohexane. This reaction occurs with alkyl benzene. Any alkyl group is here. So if there is only methyl group, then remember that halogenation occurs only at this side chain of the alkyl. And in this condition, it never occurs on any other carbon of the benzene ring. So it produces chloromethyl benzene. It was the methyl benzene, and it is chloromethyl benzene. And if there is ethyl benzene, then in ethyl benzene, two isomers are possible. Either you react it with chlorine or bromine. One is chlorine here, and another one is chlorine on the second carbon. Name of this product is 1-chloroethylbenzene, 1-chloro, 1-phenyl ethane. And the name of this product is 2-chloro, 1-phenyl ethane. Because we prefer the benzene ring, means phenyl group, over the chlorine group. That's the name is 2-chloro, 1-phenyl ethane. If you will write 1-chloro, 2-phenyl ethane, then it would be considered wrong. This is the correct one, and this is the wrong one. The second method for preparation of halogenoalkane is the electrophilic addition of halogens halogens to alkene. So first of all, we will see the reaction of very simple hydrocarbon, simple alkene, that is ethene, CH2CH2. So when you will add a molecule of bromine or chlorine, it produces 1,2-dibromo ethane. On both the position there are bromine, and the name is 1,2-dibromo ethane. And if the same reaction is carried out with propene or any other alkene, the same product will be obtained. And remember that no heat or other conditions are required. It occurs at room temperature. RT is represented in both the capital or small letters, or even if it is not written, then you can understand that what's going on. And this is the propene, and from propene you will obtain 1,2-dibromo propene, or if there is chlorine, then you will produce 1,2-dichloropropane, 1,2-dichloropropane. And if alkene is cycloalkene, for example, this is cyclopentene. This is cyclopentene. And you perform the same reaction here. Then you will obtain 1,2-dibromocyclopentane. One is over here and one is over here. So you will obtain 1,2-dibromocyclopentane. Why it is cyclopentane? Because there are 5 carbon atoms. So you have seen that electrophilic addition of halogen gives dihalo product. But when you carry out this reaction with halogen acids, two alkenes, then you will obtain monohalide products or monohalogen alkanes. So you can see one of the example is that you have already seen that CH2, CH2, ethene reacts with HBr and it produces 1-chloroethane. And if you perform the same reaction with propene, then you will obtain 2 products. It should be UV, not UV. This is at room temperature. And the product here would be 2-bromopropane as a major product, while 1-bromopropane is a minor product. So the name of the product is 2-bromopropane, and here it is 1-bromopropane. This is the major product, and this is the minor product. I will explain it in after one reaction. See one more thing. If you have this compound and double bond is here, and you perform the same reaction here. Now first see the name of the compound. The substrate here is 1, 2, 3, 4. 2-methyl 4 carbon atoms, so it is but-2-ene. When it reacts with HBr, it also produces 2 products. In one, bromine is substituted on the same carbon atom. So the name of the product is 2-bromo 2-methyl butane. While the other product that is formed during this reaction is you can see here that bromine is substituted on this carbon atom. So the name of the product becomes 2-bromo 3-methyl butane. So why it happens? Important point is this. Remember that this is the major product and this is the minor product. So what is the reason for the formation of major and minor product? This is called regioselectivity. So the reason of regioselectivity, you can see the structure of propene. There are two possibilities because when you will see the mechanism, in the mechanism, first the hydrogen ion is added. So when hydrogen ion is added, so there are two chances. Then whether hydrogen is added to this carbon atom. When hydrogen comes over there, then the positive charge generate on this carbon. See how that the double bond attacks on the hydrogen ion. If hydrogen ions attacks from there, then it binds to this carbon atom, that is the second carbon atom, and it produces positive ion on the terminal carbon atom. While on the other side, if hydrogen ion, this is the hydrogen ion, and if it forms a bond from there, then what is the product? You can see the positive ion will be formed on the second carbon atom. And the second carbon atom is the 2-degree carbon atom because it is bonded with two other carbon atoms. So this is called secondary carbocation. And this is the primary carbocation. And the secondary carbocation is more stable than the primary one. So that's why the major product is that which is obtained through the secondary carbocation. So bromine comes on the second carbon because after that bromine attacks on the carbocation. On the other hand, you have 2-methyl butene. Again, there are two chances. Whether the hydrogen ion this hydrogen ion attacks on this carbon atom, that is a 3-degree carbon atom, but what happens? It produces, see here, H comes over here. So the positive ion is generated here. But there is another chance that instead of here, hydrogen ion is attacked by the other carbon atom. Means pi bond attack in a way that hydrogen ion bind to the this carbon atom, that is the third carbon atom if you number from here 1 2 3. So if hydrogen ion is attached here, then this carbon atom becomes positive. And this is the tertiary carbocation or 3-degree carbocation. Tertiary carbocation. And this is the secondary carbocation or 2-degree carbocation. secondary carbocation. So it is very clear that primary carbocation are less stable as compared to secondary, and secondary carbocation are less stable as compared to tertiary carbocation. That primary carbocation is less stable as compared to secondary carbocation, and secondary carbocation is less stable as compared to tertiary carbocation. So that's why you can understand why these are the major product. So there are two chances that whether the primary carbocation is formed by adding hydrogen over here, or whether it forms the secondary carbocation. So if the secondary carbocation is more stable, so this is the major product, and one that is through the primary carbocation is less stable. And similarly here, the major product is the tertiary, because the tertiary carbocation is more stable. So that's the reason. So you have seen that there are two methods of electrophilic addition that generates halogenoalkane. One generates dihalo products, and the another one generate monohalo product. The third method is the substitution of alcohol by PCl3 by heating alcohol by PCl5 at room temperature, SOCl2 at room temperature, D with HCl, or HBr, and E is with KCl with concentrated H2SO4. So this is the third method for preparation of halogenoalkane by substitution of alcohol by PCl3 by heating, PCl5 at room temperature, SOCl2 at room temperature, HCl or HBr at room temperature, or with KCl or NaCl with concentrated H2SO4 or H3PO4, because actually this mixture ultimately produces HCl, or if you will use KBr, then it will produce HBr. So it can be carried out by any of these reagents. If you have ethanol, that is CH3CH2OH, and it undergoes a reaction with PCl5, it produces its alcohol, respective alkyl halide. If it is PCl5, then it would be CH3CH2Cl, that is chloroethane. Chloroethane. Similarly, if you have pro propan-1-ol, propan-1-ol, and you react it with any of the reagent which are given here, it produces its respective halogenoalkane. So it is 1-chloro propane. And if there are OH on two positions and you use 2 moles of the reagent, for example, PCl3, and you heat this mixture, then it produces 1,3-dichloropropane. 1,3-dichloropropane. And it was propane 1,3-diol. For example, cyclohexanol. Cyclohexanol. It can also undergo substitution reaction with any of the reagent. For example, KCl in presence of concentrated sulfuric acid, and it produces its respective halogenoalkane, and this is chlorocyclohexane. Chlorocyclohexane. Okay, now see the byproduct which are obtained during the reaction of these reagents. So here the ratio is 1:1 when they react in 1:1 ratio. One chlorine combined with hydrogen to produce HCl, while other one produce halogenoalkane, that is chloroethane in this case, and one of the oxygen combined with phosphorus to produce PCl, POCl3. And in case of SOCl2, again the ratio is 1:1 for reagents, and the product, one of the product is HCl with the same manner. One chlorine combined with hydrogen to produce HCl, while both of the oxygen combine together to produce sulfur dioxide gas. So during this reaction, you will feel the burning sulfur smell due to the production of SOCl, SO2, SO2. And in case of PCl3, 1 mole PCl3 is enough for 3 moles of OH. So here there are two OH molecules. So we can consider that 2 moles, 6 moles, 6 or 3 moles. If you use 3 moles of this alcohol, so it consumes 2 moles of PCl3 and it produces as many HCl as many OH are there. So as there are 2 OH molecules, so they produces H3PO3. Okay. If it was 1:1 ratio, then 1 PCl3 produces 3 halogenoalkanes and 1 molecule of H3PO3. But as there are twice OH group on the our substrate molecule, so 2 moles are required. So 2 moles of H3PO3 is required. And for a simple reaction, you can see this example. For example, you have propane 1-ol, propane 1-ol, and you react it with PCl3. So it requires 3 moles of alcohol, and as a result, it produces 3 moles of respective alkyl halide and 1 mole of H3PO3 phosphorus acid. The name of this compound is phosphorus acid. And this is 1 chloropropane, 1 chloropropane. Okay, now the case where KCl is there, it produces its respective. So the byproduct is water. If you are going to balance this equation, then you can understand that it is already balanced because one hydrogen from HCl and one hydrogen is already there. So H2 is formed from there and halogen is substituted over there. While this potassium form potassium sulfate with sulfuric acid. So in organic chemistry, actually, we deal with the organic compounds only. So we can ignore the byproducts obtained over there. Now see this example. This is the substituted phenyl substituted alcohol. And the name of this alcohol is 1, 2, 3. 3-phenyl propane 1-ol. When it reacts with HBr or HCl, it produces its respective alkyl halide. If it is Br, so there would be Br. So the name of the product is 1-phenyl 3-bromopropane. 1-phenyl 3-bromopropane is the product. And the side product would be water.